Right now we're going to look at drawing shear and moment diagrams. We're going to have a fairly simple load condition. We're going to have a 10 kip load supported simply, 6 foot, 4 foot. And I'm going to determine that the reactive forces are 6 kip and 4 kips. And we're going to you'll do that on your own. We're not going to make this part of the problem. And the process we use is the first thing we do is we draw extended lines down, light lines down from the key points. The supports, the loads, and you'll see this makes drawing the shear and moment diagrams better. I'll work at you'll use a ruler. I will get better as I do this along. And this is where drawing things to scale really comes into play. And so the first thing we have is the load, or the free body diagram. And the next thing we draw is the shear. And the shear we call V. And we have some sign conventions we need to talk about. On what's positive shear, what's positive moment. And in shear, up on the left, down on the right is positive. Down on the left, up on the right is negative. These are just sign conventions. Up on the left, down on the right is positive. For moments, bending that cups up is positive, bending that cups down is negative. So another way to put it is if you have the top in compression, it's positive, or the bottom in tension, that too is positive. So what we're going to do is we're going to take our eye and we're going to go from left to right. And we're going to look from left to right. And the first thing we see going from left to right is we see a 4 kip load. A 4 kip load right at the beginning. The only thing that changes shear is load. If you don't have a change in load, you don't have a change in shear. So it carries on and still until it sees a load, which is 10 kips down, which is a change in load. And we're going to say down is negative. So we're going to go down 4 and then 6 more. So this is 4 kips here, and this is minus 6 kips here, and the difference between 4 and minus 6 is 10. And we're going to go across. We have no change in load, so there's no change in shear till we come to this 6 kips, and it takes us back up to 0. So repeating, going from left to right, 4 up takes us up, no load, no change, 10 down, goes 4, 6 more to 10, go across, no load changes, and then we hit the 6 going back up. So that's our shear diagram. Now we're going to do one other thing here to make things easier for us. If we have 4 kips over 6 feet, that's 24 kip feet. And if we have 6 kips over 4 feet, or negative 6 kips over 4 feet, it's going to give us negative 24 kip feet. And that's going to help inform the moment diagram. Looking at the moment diagram, we're going to draw our 0. And the moment diagram is a measure of the change in area of the shear. So, looking at the moment diagram, just at the point of support, there's no area of the shear diagram. Then when we get to the point here, the area of the shear diagram to the left of this point is 24 kip feet. So we're going to graph 24 kip feet. Now, for every foot, it goes up 4 kip feet or in a straight line. So we're going to draw a straight line because it goes up uniformly. And this is going to be 24 kip feet. Then on the way down, we're going to look at this point, the end point, and we're going to say I have plus 24, negative 24, so we're going to end up at 0. And again, it's going to go down by 6 kips a foot over 4 feet, or a straight line down to 0. And that essentially is our shear and moment diagrams. And we can use this to design or check the design using moment maximum or shear maximum. And it allows us to visualize the forces and the stress within the beam. We'll do more of this, but this is drawing a shear and moment diagram.